is section 3. So 5-3. Partial decomposition.
Thank you.
I thought she was leaving.
Oh, you can ask me to close.
So basically all this is doing something backwards, and we haven't been able to go backwards with this method until we learn systems of equations. So this starts off with something silly. How do you add those two together?
Common denominator.
Common denominator. What's the left one missing?
A 4. I mean, x plus 4.
An x plus 4, so you put it in the top, and you put it in the bottom. What's the right fraction missing?
X plus 2.
And if you put it in the bottom, you also have to put it in the top. This is not an equation where you multiply both sides of the equation by the common denominator. This is what you're doing to generate a common denominator. All right, so the next step is, what is the common denominator?
X plus 4, x plus 2.
X plus 4, x plus 2. And in the numerator, you're going to have 5 times x plus 4 minus 3 times x plus 2. Most people make the mistake of not writing the denominator and just writing the numerator and coming up with just a single linear answer. All right, so what does the top become?
5x plus 20 minus. How do you want it?
Oh, either way.
Step by step.
5x plus 20
Minus 3x minus 6.
all over x plus 4, x plus 2, or x plus 2, x plus 4. Doesn't matter what order it goes in. And then finally we get down to 2x minus 6 over x plus 4, x plus 2 is our final answer. All right, so that's the old thing, the thing we've done before. So what partial decomposition does is it takes this thing and breaks it apart back into the original thing. So it takes a combined fraction and rips it apart into its pieces. That's why it's called a decomposition, partial decomposition. And you'll notice that the pieces in this case, x plus 4 and x plus 2 become the denominators of the two separate fractions. And the things in the top are always going to be, and I gotta emphasize this, the numerators are always 1 degree less than the denominators, at least 1 degree less than the denominators. So you'll see here, 1 degree less than linear is a constant. Down here, if I multiply together x plus 2 and x plus 4, the highest degree is 2, and the degree in the top is 1. It's always going to be 1 or less in the degree. So you're not going to see these fractions with the same degree going across like when we dealt with graphing rational functions, because then you could always do long division and break it down a little bit differently. All right, so how are we going to go backwards? Well, I'm just going to give it to you in one fell swoop. There are 3 basic setups. There's the setup of the one that I put together and eventually we're going to rip apart. So if you have something like, let me just write it, 2x minus 6 over linear factors. Wow, that squeaks a lot. And these are what I consider linear factors. And we're only really worried about the denominator. As long as the numerator is 1 degree less, at least 1 degree less than the denominator, all you focus on is the denominator. You don't really care too much about the numerator after that at the top. All right, if there are just linear factors in the bottom, then this is going to break apart into a constant over the first factor plus a constant over the second factor. If there were 3 linear factors in the bottom, you'd have plus c over the next factor, plus d over the next factor. So it kind of just can get really quite long. We'll do one of those at the very end of class.
Why'd you put 4 and the other one you put Z? Oh, that's a 2.
2.
It looks like
Worry about your vision. All right, so what happens if I take something that looks like this? Oops, that's a 2. This as a quadratic factor. Something that cannot be broken down. X squared plus 4 cannot be factored. So the least simplified version of it is just x squared plus 4. You can't do much else with it. When you break something like this down, because it's a quadratic factor, it goes back to the general rule. The top has to be 1 degree less than a square. So what kind of things are 1 degree less than a square?
X.
X by itself would be fine, but what if it has a coefficient? You know,
Constant.
you'd need a constant, so AX would work out perfectly fine, but AX is not the end of that type of term. It could be AX plus another constant, right? Something like x plus 2, or 2x plus 3, or 4x minus 5. So when I write this numerator here, I have to write a linear factor, AX plus B. Because the numerator can be a maximum of 1 degree less than the denominator. And a factor would have to have some kind of coefficient for x plus a constant. That would be linear. Ax plus b is kind of like y equals mx plus b. It's considered a linear factor. Because the second factor is just a linear factor, what would I write as my last part of my fraction? What would you put on top? Any guesses?
B.
I already have a B.
C.
C. So you kind of just go down the alphabet, capital letter wise, to get you to the next piece. So that's what would happen if you had a quadratic factor. If you had 2 quadratic factors, then you'd have to use like cx plus d in the second piece. All right, how about this type? What if I had 2x minus 6 over x minus 3 all squared times x plus 1? This one is considered perfect square. But it also works if you use higher powers, cubed, fourth, and so forth. And the pattern kind of follows along. I'll show you one of those later. I would never solve it because they get kind of nasty. When this setup is available, then when we do this, you're automatically going to have 2 fractions from the first one. Automatically going to have 2 fractions from the first one. You're going to get x minus 3 as a single linear factor on the bottom of the first one. And then x minus 3 as a perfect square for the second one. And then lastly, you have that x plus 1 down there. So that would be your last fraction, x plus 1. Now, probably most confusing one is this last one. Because of that square, you're thinking it's a unfactorable quadratic. But x minus 3 in and of itself is still linear. It's still a linear thing. So this becomes a over x minus 3, b over x minus 3 all squared, c over x plus 1. Because literally each one of them is a unfactorable linear factor. And those are your 3 setups. Do you have to memorize them? Heck yeah. Are they easy to memorize? It depends on how you think of it. You just have to remember 1 degree less in the numerator. 1 degree less in the numerator. So let's start off with a simple one. I'll get to it. Simple one. x plus 7 over x squared minus x minus 2. And I want to perform a partial decomposition on it. So what should happen first? Do what? Break the bottom. I assume you mean factor. So if you factor the bottom, what does it become?
X minus 2, x plus 1.
X minus 2, x plus 1. So the denominator has to be factored. Numerator, not so important. All right, how am I going to decompose this? What kind of factors are in the bottom? It's all recognition now. They're linear. So since they're linear and they have nothing to do with one another, you're going to get a over the first one plus b over the second one. When you look at this is literally an equation. We're not trying to solve for x though, we're trying to solve for a and b, those coefficients. We're unsure what they are. But even though you're trying to solve for a and b, the same setup still works from the first chapter of teaching how to solve linear equations. What's your first step? What don't you like about this equation?
The bottom.
Multiply both sides by the bottom, also known as what kind of denominator? Common, thank you. So multiply both sides by the common denominator of x minus 2 and x plus 1. Literally multiplying every single factor or piece by the common denominator. So when you do that, on the left-hand side, they both go away, which is rather nice. With the second piece, the x minus 2's go away. With the third piece, the x plus 1's go away, and there are no more fractions in this equation. So that's a common goal with every single one of these. You get rid of the denominator, and it's usually just multiply by what's in the bottom on the left-hand side, and it'll work out fine. What's left on the left?
X plus 7.
X plus 7. What's left on the right?
A plus A.
A times x plus 1
I'm going to
plus b times x minus 2. Now there's a reason I like writing this stuff. At the end of the lesson, I'm going to show you a shortcut to do something a little bit different, and it needs to be in this setup. All right, but because I'm not doing the shortcut yet, let's expand it. So this becomes x plus 7 is equal to, while I expand it, and there's a reason I'm going to be doing this, I'm going to collect my x's and collect my constants. So if I collect my x's, it's ax and bx. So how do I write that as a single term of x?
What now?
If I have ax plus bx, how do I write it as a single term of x?
AB plus times X.
A times b times x?
No, AB times X.
But ab is a times b.
A plus B.
Ah, a plus b times
A.
x. Plus, what are my constants? Well, what's that give me? A. What's this give me? Negative 2b. So my constant literally is a minus 2b. If a and b were numbers, that would combine as a single constant number. All right. So trick time. I'm going to ask a silly question now. Let's see if you can answer me. If I have 3x squared minus 2x plus 1 is equal to ax squared plus bx plus c, what's a equal to? 3. What's b equal to?
2.
Nope. Negative 2. What's c equal to? 1. polynomials are a one-to-one correspondence with their coefficients. The only way that these two polynomials are equal to each other is if their coefficients are equal. So when I look at this equation and I see x plus 7, what's the coefficient of x? 1. And the constant is 7. What's the coefficient of x on the other side? What's the coefficient of x on the right-hand side? How do I know the coefficient of x on the left-hand side is 1?
Because it's a variable.
Because it's the number to the left. So what's the coefficient of the variable to the left of x? Or the coefficient left of x? A plus b. And what's the constant of this side? Oh, that's a minus 2b. So a plus b has to be the same as 1, not 1x, 1. Like over here, a literally is equal to 3. Has nothing to do with x's. So I get the equation, a plus b is equal to 1. The coefficients have to be exactly the same under polynomials. All right, so what's a minus 2b equal to?
7.
7. So what you have here is a system of equations and two variables, the variables being a and b. How do you want to solve? Your choice. Substitution? Elimination? Elimination? All right, if I'm going to do elimination.
Which one's easier?
Which one?
Which one's easier?
I like elimination all the time. That way I don't have to worry about substitution. If the coefficients weren't integers, then I'd probably lean towards
So would you
substitution.
be moving it over to have equal to 0?
Mhm.
Okay.
When we're doing elimination, you try to line these up so something cancels.
Yeah.
So what's the easiest variable to cancel between these two? A. So I would take the first equation and multiply it by negative 1. So if I take this one, multiply by negative 1, and write it down here, I'm going to get negative a minus b is equal to negative 1. And add them together. So what do you get?
Negative 3b,
Negative 3b is equal to
6,
6. And therefore b is equal to
negative 2.
negative 2. So it found me one of my coefficients.
That's pretty good.
It's all right. So if I know b is equal to negative 2, how do I find a?
And plug it in.
Plug it into one or the other equation. This one seems to be easier. A plus b is equal to 1. So it becomes a plus negative 2 is equal to 1. So a is equal to 3. Not bad, right? Now these can turn into fractions, which make them just look weird. I'll probably make up one later just to see what to do with fractions. All right, so if I take these two answers and I plug it back into here, because that's where it belongs, we're trying to break this fraction into two pieces, we're going to get a is equal to 3, so this becomes 3 over x minus 2. And b is equal to negative 2, so I'm going to write it minus 2 over x plus 1. And this is the exact same thing as x plus 7 over x squared minus x minus 2. Exactly the same as x plus 7 over x squared minus x plus 2. If you literally add these together by getting a common denominator, this is the answer that will spit out if you multiply the bottoms together. Now, any questions? There's one obvious question.
Are you done?
I'm done. There's another obvious question. Aren't you at all curious why I've been teaching this? What's the purpose of
I'm
this?
sure you'll tell us.
Of course I'm going to tell you, but I was hoping you would ask and go, Mr. Glory, why the heck are you even showing this? It makes no sense to rip them apart. Well, if you ever get to calculus, and that's really the only place I've ever used this process, if you get to calculus, performing this operation on this piece is impossible. Absolutely impossible. But performing it on this piece is simplistic. Very, very easy to figure out. So on the right, that operation, you don't even want to know what that operation is because it's too hard to explain. But trying to do this in calculus is impossible. But doing the left-hand side, doing the exact same operation is simplistic. So by breaking it down, we take a hard problem and make it easy for calculus. That's all this is about. It's the only reason I can think of using partial decomposition. Other than playing around with systems of equations, which is kind of fun. All right, so that's the linear setup. Linears are always the easiest, and there's shortcuts to linears also. But it doesn't work in all cases, so I'm going to do it the long way.
Can you not erase that slide yet?
That one?
Yeah.
Oh, you're going to write that symbol? It's also known as an integral. 8x squared minus 15x plus 6 all over x cubed minus 2x squared plus 4x minus 8. There, that's the base. So, what do I need to do first? Stare at it, okay.
Let me write it down.
Write it down, I guess that's a good first thing.
Common denominator.
No, not yet.
How about you write it in the no?
Oh, you said it earlier on the first one.
Yeah, baby.
Write it down.
Break it down.
Write it down.
Gotta
Oh,
factor
you
it.
want me to break it down?
Gotta break it down. So how do you factor this mess?
Synthetic division.
How do you factor? Well, you could do synthetic division,
That's your thing.
but I always try
You see
something
this picture,
before
Yes.
synthetic division.
part two.
Like, oh, I've seen the
Remember when they
minions
came
too.
shot, she was like, little crunchy.
What?
Nothing.
I don't even want to know. So,
Very bad.
besides jumping right into rational root theorem and synthetic division, usually you try to do something else before you jump into those two. So what's another method of factoring this? You don't know?
Andrew, why don't you answer?
Andrew, why don't you answer?
I'm joking. That's what I thought about when you said break it down. Man,
No?
But that 8 over on one and,
Nope,
no.
that's rational root theorem. I'm trying to avoid that for now.
Okay.
Why did you just group the two?
Pull out,
Ah,
add on,
thank you.
pull out.
Group and factor. So you group the first two together, pull out what's common, group the second two, pull out what's common. There's 4 factors, so grouping and factoring sometimes works. It doesn't always work, but it sometimes works. What's the GCF of the first two?
X squared.
X squared, what's left behind?
X minus 2.
GCF of the second two,
4.
including the sign.
Negative 4. No,
Positive
Plus 4.
Positive 4, left behind,
X minus 2.
and then I can yank out,
X squared plus 4.
well, I can yank out x minus 2 and leave behind x squared plus 4. X squared plus 4. Can you factor x squared plus 4?
Mm-hmm.
No.
It has
It's
to be
a-
X minus 4.
It has to be x squared minus
in order
4.
for it to be X squared.
So I'm going to rewrite this as 8x squared minus 15x plus 6 all over x minus 2 times x squared plus 4. Are you complaining about another chair?
No, it's actually broken. That's how I say it.
You want mine? It's nice and cushy.
Yes.
Okay, so what is the basic breakdown with something that has a quadratic factor left on the bottom?
X plus B over X squared plus 4
Ax plus b over x squared plus 4.
plus C all over X minus 2.
Would be the partial decomposition common breakdown for that type. Now the order doesn't matter. You could have also done a over x minus 2 plus c bx plus c over x squared plus 4. You could switch these two.
Oh,
And then it would just be a here and b and c on the other one. So order doesn't matter. All right, now I have the perfect setup. What do I do? Oh, I'm sorry.
have at it.
Okay, what do I
Common
multiply both sides by? The
denominator.
common denominator, which is
x squared plus 4x minus c.
And you multiply everybody by that. Okay. So that gives us, on the left-hand side, for those that are quick of writing,
Hey, I answered your question, okay? I don't see anybody else doing that.
well, be quiet and let them try to answer it.
Yeah, Andrew, go for it.
8x squared
minus 15x plus x.
is equal to
AX
Plus b
ax plus b in
times x
parentheses
minus 2
times x minus 2 plus
plus c times x squared plus 4.
x squared plus 4. Okay. This does not seem to be as pretty as the last one. Life goes on. All right, next step. This doesn't change. Is equal to. Now, when expanding this is just a suggestion. You don't have to do it my way. But while you expand this, try to collect like variables. For instance, when you do ax times x, what do you get?
X squared
Is there any other chance of an x squared in that whole other right side?
cx squared.
The cx squared. So when I gather them together, what's it going to become?
A would it be oh, you're trying to simplify it out.
So you get a
Plus c
plus
times x
c
squared.
times the whole thing, x
Oh,
squared.
no wonder I wasn't getting what the heck you were writing. I didn't get that concept, that's all.
Oh, okay. When you're combining like terms, you're adding, so therefore you
Yeah, but
factor out the
I do it. I have to do it in step by step.
Well, if you have to do it step by step, that's fine. I'm just
No,
trying to
it's okay.
shorten the problem. All right, when I multiply bx and ax. Oh, I'm sorry.
Yeah, it's wrong.
Not bx and ax. bx and ax times -2.
What?
The inner and the outer. The inner and the outer.
Oh,
Those are going to give me linear factors. ax times -2 and bx. Am I going to get an x from the other one?
No.
no.
No. So all I have to worry about is those two. So how do I combine them as a single x?
Would it be a plus b?
Hmm.
What did you say again?
It's ax times -2,
Okay, so it's negative 2ax.
so it would be -2a.
Oh,
And
plus
then
b,
b times x would be
plus b.
plus b. And if you distributed that out, you'd get
You'd get
-2ax plus bx. All right, what about constants? Where am I going to get constants out of
The
this?
last one.
b times -2 is one constant. What's the
And
other one?
then c times 4.
C times 4 is the last one. So if I group those together, I'm going to get plus,
You can take out a 2.
no, I can't take out, I don't want to take out anything
Oh,
other
you
than
are.
x. There's nothing I'm going to take out, so what's left for the constant?
Negative 2B.
-2b
Plus 4c.
plus 4c. Try to squeeze it in there. Okay, so here's my long equation. When I get this long of an equation, I have three pieces. I have an x squared piece, an x piece, and a constant. That means I'm going to have three equations. And obviously three unknowns because I have an a, b, and
c.
c. All right, so let's start off with the setup of our equations. What's a plus c equal to? What is it?
8.
8.
Oh.
Why? Because a plus c is next to x squared, and on this side x squared has a 8. What's -2a plus b equal to?
-15.
-15. And then lastly, we have -2b plus 4c,
Which is 6.
which is just plain old 6. Okay. Now this one, elimination doesn't work really well. Because this first one has an A and a C. The second one has an A and a B. The last one has a B and a C. So elimination is not the best way to do this. So the other option is substitution. But you have to do it in a logical way. So if I start setting this up as a substitution and solving this first equation for A, and I get it, A equals 8 minus C, then more than likely it'd be best to take the second equation and also solve it for
A and B.
A.
I mean A.
So when I get this one as A and this one as A, it's not going to work, is it?
No.
Well, I guess I could
I
say
mean it could.
you can set them equal to each other, but it's not going to help you. So it's better if you take the first equation and solve it for C, and the second equation for
B.
and when you substitute B and C down here, you'll be left with equation all in terms of A.
Oh, so like you should.
I'm trying to push one variable all the way to the end.
Okay.
So this first one I'm going to write as C equals 8 minus A. The second one I'm going to write as B equals 2A minus 15. When I push the negative 2A across, it becomes positive. And then I'm going to take both of these and do a double substitution into that last equation. Get rid of the B, get rid of the C, and replace it all with A. So, what does it look like when I do that? I'm going to bring it way up here. So it's negative 2B plus 4C is equal to 6. So what's B equal to? Oh, slow down.
Then 2A plus 2A minus 15.
I'm going too fast.
You are, because like by the time I understand it, you're just writing it
Oh,
down.
I'm sorry.
This is why I like the pause button is so helpful.
2A minus 15 is B plus 4 times something, and that something is
8 minus
8 minus A. I'm not saying this is the only way that works, it just seems the most logical. So sometimes before you start moving anything around, you try, to focus it into one direction. You could do elimination on this, it's not pretty, but you could. So this would become negative 4A plus 30 plus 32 minus 4A is equal to 6. Let's see, that becomes an ugly mess.
negative 8A
Negative 8A
plus 62
plus 62
equals 6.
equals 6. Negative 8A is equal to
Positive 50.
Nope.
I mean negative 56.
negative 56. How many times does 8 go into 56?
7 positive.
7. So A is equal to 7.
Ooh.
Isn't that crazy?
Mm-hmm. Go for the 8
Oh, it gets worse. Now, how do I figure out another letter besides A? Where would I go?
So A and
Plug it
C
into
first
the
one.
first one.
I plug it in right here. So C is going to equal 8 minus 7, so C is going to equal 1. Once you get the first one, the rest of them are actually kind of easy. B, we're going to get B is equal to 2 times A, but A is equal to 7 minus 15. So that's 14 minus 15, better known as negative 1. So my final answer,
You said it's gonna get ugly. Didn't it get ugly?
oh, well, it got ugly here. But once you find that first letter,
I couldn't reach it.
so
It's gonna be in your video, not mine.
don't text me. Okay, so putting these all back together
Oh my god.
into the final answer.
Look at that big box that he came up with.
That's in a great box. Let's see. The final answer has to go into this piece. My arrows get messed up. Okay. So AX plus B. A is equal to 7. X plus b. What's b? It says ax plus b, so I get 7x plus -1, so it would be 7x minus 1 over x squared plus 4 plus c, which is just 1, over x minus 2. And that would be the partial decomposition of the original ugly, nasty polynomial. Not bad, right? It's a lot of writing, but it's not hard math. It's actually kind of simple math, stuff you've done before. What, one whole page for one problem? Awesome.
You mean to?
Can I erase this now?
Don't erase the other side.
I won't. Just erase this half. So for now, it's just a technique. To use it requires you to keep on going, on trucking. Take a lot of other math. Example number 3. Oh, sorry. Two x squared
Okay, let me borrow your notes.
minus 25x plus
Serious.
57. You could always watch this later. Over x cubed minus x squared minus 8x plus 12.
Factor over.
Is it going to work? No. Because the only thing you can factor out of the first two is x squared, and the only thing you can factor out of the second two is 4, and it leaves you with a 2x minus 3, and it's not going to work out really well. So the only other option is,
I don't want that option.
you don't like that option, but what's the only other option?
Less.
Rational root theorem. So 12 over 1, that's going to leave us 1, 2, 3, 4, 6, and 12. Plus or minus by the rational root theorem.
How many more examples we got left?
1.
Okay.
Yeah, just 1. It'll be the shortcut one. You want to do the last one.
Yeah, let's
There's
do
a
it.
quicker way of doing this once you get it back here.
Yeah, one that doesn't take like half a page.
Yeah, this will be quick. All right, so what do I want to synthetically divide? I'll do quick. 1, -1, -8, 12. What number do you want to start off with?
1.
Oh, why not? 1, bring down the 1. 1 times 1 is?
1.
1 minus 1 is?
0.
1 times 0?
0.
0 minus 8?
-8.
1 times -8?
Doesn't work.
Doesn't work because that leaves us with 4.
Doesn't work.
Okay?
-1.
-1. 1 times -1, -1 minus 1 is?
-2.
That sounds like an option here.
You did.
-1 times -2 is 2, 2 minus 8 is? -6. -1 times -6 is 6, 6 plus 12 is?
It works.
18, does
Oh,
not.
it doesn't work?
No. -1
never
times
mind.
6 is 6, 6 plus that is 18.
Dude.
2 times 1 is?
2.
2, 2 minus 1 is?
-1 and 1.
2 times 1?
2.
2 minus 8?
-6.
2 times -6?
-12.
-12?
It works.
0. It works. Great. So one of the factors is definitely
Negative. I'm at 2.
factors.
X minus 2.
X minus 2. All right. Then we have left over x squared plus x minus 6. Does that factor?
Yeah.
I'm doing the right one. Okay.
X plus 3x minus 2.
So this is x minus 2 times.
X plus 3x minus 2.
Oops, I wrote it wrong. There we go. But it's also better known as x minus 2 all squared times x plus 3. Because there's 2 factors of x minus 2. Okay, get rid of all this. So that means I can rewrite my problem properly. clearly as 2x squared minus 25x plus 57 over x minus 2 all squared times x plus 3. What is the breakdown or decomposition general setup for this one? This is the trickier one. This is the one everybody forgets.
A over x minus 2
Over the linear factor x minus 2 plus
b over x minus 2 squared.
over the square term. By the way, if it was raised to the third power, you have the linear factor, the square factor, and the cube factor. It's kind of crazy when the powers get higher.
Plus c.
We already have b.
I said c.
Oh, c over
X plus 3.
x plus 3. These, I think, are hard only in the setup, but then the rest of it is easier than the quadratic. Because the quadratic you have to FOIL and collect x squared terms and all that. Alright, so what's the common denominator here? Is a
Why?
why what?
X minus 2
Twice?
and then x minus 2 squared.
There's a reason for that. If I only write the x minus 2 all squared and get a number above it, it doesn't, there's a possibility that you're missing a factor. I'll show you. I have ones that are generated to show you why it's there. Because even if you don't put it there, it shows up. It's weird. Okay, so what do I do?
Common denominator.
Multiply both sides, and I'm just going to circle it by this mess. When I multiply both sides, it disappears on the left, and then things are left alone on the right. So this becomes 2x squared minus 25x plus 57 is equal to a times what? Oh no, this is nasty. Oh well.
X plus 3 and x minus 2.
And one factor of x minus 2, because only one of them is going to cancel. Because there's two of them that are hitting it. Bridget, take it. All right, what about the b?
B x plus 3 plus c x minus 2 squared.
Yeah, I'm sorry, this one's worse. All right, let's concentrate on the right-hand side. I'm just going to expand it out. So this is a times x squared plus 1x minus 6 plus b times x plus 3 plus c times x squared minus 4x plus 4. There, speed it up a little bit. I'll do the foiling first and then collecting like terms. So where am I going to get x squares?
The first and the last one. So a plus c x squared.
A and c. So this would be a plus cx squared plus x terms,
A, b,
ax, bx,
plus, oh yeah, cx. I meant 4c. Negative 4.
c. So we're going to get a plus b minus 4c. And then lastly, the constants. I'm out of room here.
A, b, negative 6a,
Negative 6a
3b,
plus
plus 3b,
3b
plus 4c.
plus 4c.
Why don't you erase the first one and rewrite that?
No, that's fine.
Like, look
The
how
dotted line's not the end of my screen. It fits. Alright, now come up with our equations. Woohoo! Did you finish writing? Go ahead.
Are you sure?
Yep, I'm pausing.
How long many pause is this?
Until you finish writing. Hurry up.
Just go ahead.
Fine.
Yeah, put that voice out of this video. It's up there too much.
A plus C equals
2.
2. A plus B minus 4C equals.
-25.
And finally, the nasty one, negative 6A plus 3B plus 4C is equal to
I'm at 57.
57.
That does look so over.
But we can make our lives a little bit easier. What would make our lives easier? What could we do? Recognizing what's here. This equation is in A and C. The other two are in A, B, and C. So what can I do to the other two to make it look more like this one?
Make it do
Take out B.
Take out B. So you take these two equations and you get rid of the B's. So how do I get rid of the B's?
times the first one by -3.
Times the first one by -3. So it gives you negative 3A, negative 3B, positive 12C, 75.
Yeah. I think. Yep.
And upon doing that, ooh, it's not going to be pretty. Life. Negative 9A, the B's go away, plus, is that 16? C is equal to 132. And that gives you an equation in terms of A and C. Okay. So we have two equations in A and C. So what do I want to do with the first one to get rid of something in the second one? So what do you want to do to him to get rid of one of the variables over there? Andrew?
A equals 2 minus 3.
I don't want to do that. I want to eliminate. So
Okay.
which variable do you want to get rid of? A or C?
Okay.
Now if you pick A, what do I have to multiply this one by? 9. So I'm going to multiply this equation by 9 and then write it underneath that one. So that becomes 9A plus 9C is equal to 18. Add these two together. For a grand total of 25. C is equal to 150. And how many times does 20 go into 150? That's 6. 6, right? So C equals 6. All that just to get
Well,
one
that's
of
what I
those.
want first. Did you have some tests like this?
Pause.
Go in.
Okay, you did
9 times the first equation.
9. I'm still on there 3 times.
Oh, this one.
Okay, alright, go ahead. Yes, yeah. Go do what you do.
Well, I mean, the rest of it is easy. Once you get C is equal to 6, you come back to this equation. A plus 6 is equal to 2, so therefore A is equal to
-4.
-4. So that gives you A and C. And then you just pick one of the other equations. I picked the middle one. It looks
Yeah, let's
decent.
see.
So A becomes 4 plus B minus 4 times C, which is 6, is equal to -25. So that becomes B minus 20 is equal to -25, right? -24 plus 4 and -20. And therefore B is equal to?
It said a -4 plus 20.
-24. -20. b is equal to
Negative 5.
negative 5.
Look at that, damn order.
Negative 4, negative 5, 6. Wow.
Yeah, that worked out so perfectly.
And therefore, my final answer up here.
Oh my god, it's not final.
Well, you gotta rewrite it. So a is negative 4, so you get negative 4 over x minus 2. B is negative 5, so you get negative 5 over x minus 2 all squared. And then C is 6, so this would be plus 6 over x plus 3.
You said somehow you got the
What are those? So if I wrote this out in expanded form, did I erase this back?
Yeah, go.
I'm not that much of a hurry. I don't want to make you upset.
No, go.
Just put the eraser down.
Just erase it.
Bring it.
Just erase it.
Oh, I'll just erase this part. I just need that room right there. All right. Besides Angelique, how does this break down?
Area over 15. Then you B.
Hmm?
Then you B.
And then a B over,
X minus 3.
and then
C.
over,
X plus 4.
and then
X plus 2.
D over, and x plus 2. Now, if we did this the old-fashioned way, the way I've been showing you all class, you'd multiply everything by the common denominator, which is, we're still going to do that. Then you would have to expand everything out, and you would have to collect third terms, second terms, first terms, and constants. And you'd end up with an equation, 4 of them, with 4 variables, A, B, C, and D. And I've never shown you how to solve a system of 4 variables and 4 equations. It's really similar to 3. You choose a variable to get rid of a couple times, and then you choose it again a couple times, then you get rid of another variable, and it gets kind of messy. So there is a trick involved with this, but the first step still is the first step. If you multiply everything by the common denominator, what's the left-hand side become?
All that.
Hmm?
11.
Left-hand side,
2.
210. Now, I've made this one easy, but I could just as well had one in the top that started off with a cube and went all the way down. It just makes it a little bit trickier. I should have probably put an X in there just to at least show you part of the trick. But no, 210, that's fine. I think I put an X in my second example. All right, so if that's 210 equals A times what factors?
X minus 3, X plus 4, X plus 2.
Everything except for X minus 1. So X minus 3, X plus 4, X plus 2. Plus B times every factor except for X minus 3. So that would be B times X minus 1, X plus 4, X plus 2. Plus, now I definitely have to get rid of the rest of this. Can I? Yeah. Okay. Plus C times every factor except for X plus 4. So that would be X minus 1, X minus 3, and X plus 2. Wow, this is getting longer than I thought it would be. Plus D times everything except X plus 2, so X minus 1, X minus 3, X plus 4. There. Thank God for shortcuts. Now remember, the shortcut kind of works on everything else I showed you today, but it's not perfect for everything. It is perfect in this case because we have linear factors that have nothing to do with one another. In other words, you don't have any perfect squares going on, and you don't have any quadratic pieces in here also. So here's how the trick works. I could go through and set this up as a system of equations, but that would take us about a half hour to finish. So my other choice is this. Why not substitute values in for x? It's legal. As long as I do it on both sides, it's absolutely legal to let x equal anything I want it to. So what would you let x equal? That would actually help us a bit. No suggestions? Think about it for a second. What would you let x equal? So what's a zero of this nasty equation? Or a zero of at least pieces of this nasty equation?
1, 3, negative 4, 2.
1, 3, negative 4, 2. Pick one.
1.
1. So if I let x equal 1, one of the zeros of the pieces, one of the zeros of the factors, watch what happens. The left-hand side doesn't change, but if it did have an x in it, you'd have to let the x equal 1 and simplify it. So this becomes 210. Does anything happen here fancy-wise? Not really. So this becomes a times 1 minus 3, 1 plus 4, 1 plus 2. Does anything fancy happen with the b's?
I'm not getting what you're saying.
Well, if you plug 1 in here, what happens? 0. And 0 times anything else is?
0.
So this whole thing goes away. And what happens here?
Same thing.
Same thing. It goes away. So the only thing I have left is what I've written already. So let's simplify. This is 210 is equal to, let's see here, that's negative 2 times 5, that's negative 10. Negative 10 times 3 is?
Negative 30.
So this becomes negative 30a. This is a linear equation in one variable, which is easy enough to solve. So I get a is equal to?
240.
No.
No.
Are you adding?
Yep.
Stop it. Divide. You divide both sides by negative 30, you get?
Oh, that actually goes in? Oh, yeah, it does.
Yeah, it's 21 and 30.
Oh.
Oh, 21 and 3. So a is equal to negative 7. The only problem now is we don't have any other equations to plug it into. So if we were doing it to the other ones and it didn't work out perfectly, you might have to still do systems of equations. All right, but that's nice. What's another let x equal we could try?
Negative 2.
Negative 2. So if I let x equal negative 2, let's see here. The left-hand side stays at 210 because it doesn't have any x's. And what happens to the a term?
It's gone.
It's gone. The b term,
Gone.
gone. The c term, gone. The d term,
Stay.
it stays. So we're going to get d times negative 2 minus 1, negative 2 minus 3, and negative 2 plus 4. So let's see, this is negative 3 times negative 5,
15.
15 times 2.
Negative 30.
So we get 210 is equal to
30.
30d, and therefore d is equal to
7.
7. All right, take another one. Let x equal
3.
positive 3.
Yep.
Now if x is equal to 3, what happens to a? Gone. B,
Stays.
C,
Gone.
D.
Gone.
So everybody's gone except for B. So the left-hand side is 210 because there's no x's. And we're going to get b times 3 minus 1, 3 plus 4, 3 plus 2. Oops, I forgot to box mine. D equals 7. There we go. So this is 2 times 7
14.
times 5. 70. So this is 210 is equal to 70b. Therefore b is equal to
3. And the last one, -4.
Let x equal,
And the only one you have left is C.
and we get 210 is equal to the c term, because everybody else goes poof. So we get c times -4 minus 1, -4 plus, nope, minus 3, and then finally -4 plus 2. Okay. So that is -5 times -7.
What was that? -5
-5 times -7.
35.
35 times -2.
70.
Better known as -70. C. Therefore, C is equal to?
-3.
So the shortcut gets you to the answers rather quickly because it removes a bunch of the letters that are in contention with it. So by letting x equal 1, we get rid of everything and solve for a. Let x equal -2 allows us to solve just for d and so forth and so on. And then our final answer, of course, would be, a, which is -7, so it would be -7 over x minus 1, plus b, where's b? It's 3, and that would be over x minus 3, plus c, which is -3, so I really should have made that a minus. 3 over x plus 4, and then d is positive or negative, positive 7 over x plus 2 as our final answer. Kind of cool?
Yeah.
But we've skipped a lot of work by using this little shortcut. But again, I'm going to say the shortcut works great, except in certain cases. So I'll show you one of the ones we've already solved, and then show you how the shortcut kind of works with it, and then you can decide if you want to do systems or shortcut. Because when the shortcut doesn't perfectly work, you still would have to expand all of this out, collect terms, and have equations ready, so when you find one or two of the variables, you can just plug in to solve for the rest. If that makes any sense. All right.
We're done, right?
No, I wanted to show you one more. Just an old one with a shortcut. One of the first ones we did. Actually, one of the ones I skipped. So 5x squared minus 4x plus 13 over, that's a horrible 5. I'll factor it. X minus 2, x squared plus 1. So this is the quadratic version. So what's the quadratic setup?
Equals
A over
x minus 2
x minus 2 plus,
plus b. No, that's wrong.
no it's not,
You said quadratic.
it has a quadratic piece. But so far it's right, up to that point. Remember, 1 degree less than the one below it. So what's 1 degree less than x squared?
X minus
X.
I mean x.
So it's going to be bx.
I thought you were supposed to put A and B
Order-
together.
Order doesn't matter.
Plus C.
Plus c.
Oh, it doesn't matter. Okay.
Oh no, order does not matter because addition is commutative, multiplication is commutative. So order is not going to matter here. What goes in the bottom?
X squared plus 1.
Okay, so that's the setup. Now some of the questions on the test are just the setup. That's all I'm looking for. Is that piece done? You're good. Move on to the next one. The setups I usually generate are really hard, and I'll show you one of those in a second. Just the setup, not solving it, because solving it would take like all day. All right, what would you multiply by?
Common denominator.
Common denominator, which of course is this. It's always going to be this. So when I multiply both sides, I'm going to get 5x squared minus 4x plus 13 is equal to a times x squared plus 1 plus bx plus c times x minus 2. Alright. And like I said, the shortcut works on this, it just doesn't work, well, perfectly. And I just wanted to show you how to get out of the imperfectness. So I'm going to do the next line also, which is combine like terms and get the system of equations set up, and then go back to this line and use the shortcut on it. So I'm going to skip a little space here. Right? So this becomes 5x squared minus 4x plus 13 is equal to, what are my x squared terms?
A plus B.
A plus b?
No, A plus B.
Okay.
Plus C.
C has no x squares.
Okay, then it's just A plus B.
A plus b. Here you're going to get ax squared, here you're going to get bx squared. Alright, plus the x terms. Where's the only place I'm going to get x's?
C.
Cx and?
That's it.
There's one more. Remember, you're going to FOIL that. First, outer, inner, last. First gives you x squares, outer gives you negative 2bx,
Oh, negative
inner
2B.
gives you cx, last gives you negative 2c. So it's going to be negative 2b plus c, and a is not going to give you an x term.
You drew the other arrow. Reminded me.
Oh, I'm sorry. I was going to, but you didn't say anything, so I didn't draw it. All right, constant. What's left for constants? A times 1
minus 2 C.
minus 2c is the other, and that's it. All right. So bottom equation is the system setup. The top equation is the shortcut setup. So I'm going to start with the shortcut setup, but probably finish with the system. So under the shortcut setup, what's the only 0 you see up there? Is there a 0 for x squared plus 1? Well, yes, but it's imaginary.
It's minus 2, so it's negative 2. I mean, it's 2.
2. So my shortcut is let x equal 2. And I'll put that right here. Now when you let x equal 2, you have to let it equal 2 on the left-hand side also. So it's going to be 5 times 2 squared minus 4 times 2 plus 13. So 5 times 2 squared is 20. 4 times 2 is 8. 20 minus 8 is 12. 12 plus 13 is? So this side becomes 25 is equal to. When you plug in 2 here, it's not going to make it 0, so you're going to get 2 squared plus 1.
5.
So you're going to get 5a. Over here, it becomes 0, so it drops off the b. And you actually get to solve for a, which is 5, without doing very much work at all. So the shortcut gives you one of the answers. The problem is it doesn't give you the other 2, which is kind of sad. So to find the other 2, we actually have to set up the system of equations. This is a plus b equals
Negative 5. I'm at 5.
5, right? But a is already equal to
5.
5. So I get 5 plus b is equal to 5. Therefore, b is equal to
0.
0. So that gives me an answer. One of my other equations is negative 2b plus c, or a minus 2c. Which one do you want to use?
A minus 2C.
Oh, see, I would have went with the
Well,
negative 2b
okay.
plus c, but that's okay.
No,
A minus
no,
2c.
No, don't do that one. I wanted to do the other one first, but
All right, we'll see if they turn out to be the same.
no, don't do that. Do the second one,
Negative 2 times b,
which is 0.
we're doing that one, which is 0, plus c is equal to
1. No, it's equal to
this.
4.
This is the x term. What's the coefficient of x?
4. Negative 4.
Negative 4. So it's equal to negative 4. Therefore, c is equal to negative 4. Let's see if it works with the last one also. A was 5, right?
Mm-hmm.
So this would be 5 minus 2c is equal to
13.
13. Subtract the 5 across, 13 minus 5 is
8.
8. 8 divided by negative 2?
Negative.
C equals negative 4. So either way, we get C equals negative 4, B equals 0, and A equals 5. I can erase all that. Awesome. So the trick works, but you still might have to set up the systems of equations. So it's better to set up the systems and then go back to the trick and then use your trick to help you solve the system of equations a lot quicker. All right, so the final answer would be A, where's A? Oh, 5 over x minus 2 plus, well, it's not going to be plus, is it? Well, B is equal to 0, right? So Bx is gone, and all you're left with is C, and C is negative 4, so I'll go minus 4 over x squared plus 1. And that would be the decomposition of 5x squared minus 4x plus 13 over x plus minus 2x squared plus 1. Kind of cool if you think about it. So the shortcut does have its uses, it's just you can't use it exclusively sometimes. It's nice when they're all linear factors and you can just get rid of letters that you want to get rid of. I would never ask you to solve this. This is going to be really long.
You don't even have time.
I'm not trying to find the partial decomposition, I'm just setting it up so if we actually wanted to find it, this would be the setup involved. So what would be the first step? A over
X plus 4.
x plus 4. I'm going to write this really small. Plus B over
X.
X plus 20, X minus 2.
x minus 2 plus
C.
C over
X minus 2 squared.
x minus 2 squared plus
D.
D over
Is it the x squared one?
nope,
X minus 2 cubed?
x minus 2 cubed. Because it has a cube, it could also have a square, but it also could have just a linear factor. So you have to account for all of them. All right, I'm going to move to the next line because it'll just go off the screen if I keep going. So down below, plus E, just E.
X squared plus 2x minus 1.
Yes, no. I'll agree with your denominator. Sure, it's x squared plus 2x minus 1.
Oh, it has to have a less degree.
Has to have a linear factor of the smaller degree of the top. So what would be smaller? We already used A, B, C, D, so all that's left is next letter, E,
X.
X, plus
D.
F. I already
Plus
have
F.
D.
Oh, okay.
So this would be E, X plus F plus one more.
H. No.
Well, no, bottom first.
X squared plus 2x minus 1 squared.
All squared in the top.
G
A, B, C, D, E, F, G, X.
plus H.
And that would be the setup of the partial decomposition of this problem.
Watch him give us one like that.
Oh, I couldn't. 1, 2, 3, 4, 5, 6, 7, 8 letters. That means 8 equations. So 8 unknowns with 8 equations. That would take you a day.
He'd be like, set this up. Give me a
No,
basic
I'll
setup.
ask you to set it up. I won't ask you to solve.
Oh, so you would give us one like that?
Yeah. This would be your answer, and you'd be done. It's not that bad.